So last time we made this oil-filled gearbox with a worm drive in it, and then the question is, what kind of motor should we have to drive this? One of the things I bought actually in 2018 was this brushless DC motor. Rather more expensive at 34 quid than the JGY 370 type motors that I've used before, which have a gearbox that wears out. And I thought I would try that. It's called FIT 0441, and you can Google that to get a data sheet. The motor runs at 7,000 RPM, but it has a 45:1 reduction ratio in this gearbox here, and it says that the torque is 2.4 kilograms centimetre, so we'll see about that. It has some built-in electronics, so you just feed it with a PWM signal, and that controls the speed at which it goes. In fact, if you ground the PWM signal, it goes flat out, so you only really need to connect the two power lines to it. It also has a direction control which can reverse the motor, and it has a Hall effect sensor which gives you 6 impulses per revolution of the motor. It weighs 68 grams. It comes with a rather short lead which plugs in to the back there with nothing to retain it. I think I'd have to glue that in or fix it in somehow. There was some kind of plastic plug on the end of this, but as I didn't have the mating plug, I had to cut that off and join it, which is a bit of a nuisance. I'd rather have longer leads without a useless plug on the end. So what you've got here is a brushless motor with bronze bearings, and on top of it a 45:1 reduction gear, and I haven't looked inside that yet, and then a 10mm long shaft with a flat on it, and it's tapped for mounting. If you just apply 12 volts to it and ground the PWM signal, then it runs at maximum speed. I should be able to show that. This is the PWM signal, so if I ground that, that's its maximum speed, which is about, I don't know, 145 RPM. And if you ground another wire, which is a direction wire, then it goes the other way. I can drive it with a PWM signal and change the duty cycle of it with this knob. So it's 10%, 20%, 30%, 40%, 50%, 60%, up to 90, or up to 90. At 90% it goes really slowly. So 0% is fast, 100% is really slow. So that's at 90% duty cycle. So that's 70%. 10%. That's at 10%. 1.37%. Wow. Don't know why these are always upside down. That's life, isn't it? So that's at 10%, which is close to maximum speed. the bottom, the blue line, is the PWM signal, which is at 1 kilohertz. The yellow line is a Hall effect sensor inside, which produces 6 pulses per revolution of the motor. So to convert that into RPM, you've got to multiply by 60, divide by 6, and then divide by 45, which is the reduction ratio of this gearbox. You notice that although it's synced properly on this yellow signal, it keeps changing, and the frequency which is measuring down here also changes. It's about 600 Hertz, but it's not exactly stable. It's the blue line. It's not syncing on that at all, so that's reasonable for that to move around. And the power consumption at 12 volts is 60 milliamps. On no load. It goes up to 180 milliamps if I put a load on it. And you can hear also the revs goes down, but you can hear that as soon as you put a load on it, we can rather hear the gearbox complaining. That seems to me to be the case. Even a moderate load. So I'm a bit worried that this gearbox is not what I would call very robust. I wonder if I take it out of this, which is acting as a kind of echo sounder. Sounds better, but not good. Actually, I guess it's the table that's magnifying this signal. If I just touch this on the table, yes, it's a table that's acting as a sounding board, which is quite useful. Current consumption under no load doesn't change much as you change the PWM signal. It goes down to 50. Oh, okay, so it does change a lot. When we go down to really slow speed, it's only 20 milliamps. The rotational speed is not linear in the PWM duty cycle. There's another wire which you can ground to reverse the motion. It will run on less than 12 volts. If I dial it down, 10, 9, 8, 7, 6, it will run on 5 volts. Taking 43 milliamps at this maximum speed rather than 60. The output signals from this, like the Hall effect output, remain at 0 to 3.3 volts regardless of the power supply that you're driving it at. I haven't tried it below 6 volts. Shall we go down and see if when it stops? It stops at 5 volts. Yeah. So it will run at 6 volts, but not at 5. Right. Well, I've fixed this motor in place as straight as I can make it. If I ground the yellow wire, it goes the other way. I think it's as straight as I can get it. But my view is that the gearbox is sounding as if it's under strain. let me just lift it off the table. So the table is amplifying that sound, but if I hold it off the table, it still sounds. Doesn't sound too good to me. Right, I'm going to see if I can tell what frequencies are making noises using this spectrum analyzer. So I'm going to hold this. I'm going to hold this off the table. There's frequencies up here. So I've enabled peak hold on this thing. Hold it off the table, clear and go. So at 134 RPM on the output shaft, multiplied by 45, that's 6030 RPM. Which is about 100 revs per second, so I presume that's that peak. So all the main peaks are enormously much faster than that, so it doesn't tell us a great deal. Presumably we're actually listening to individual teeth on the cogs. So divide this by 2, you get to there. Divide it by 2 again, you get to there, 1.2 kilohertz. But which cog it actually is, I wouldn't like to say, so it doesn't help me a great deal. So I think we'd better take this apart, or at least take the gearbox apart. It's only got 2 screws there. Right, so usually when you take gearboxes apart, stuff falls out everywhere. Right. So from the gearbox is in 2 halves, and there's just one gear poking up there which engages with these 3 gears. Well, I've got it in pretty much of a mess now. I think that this box must be assembled from the outside, the top, first. So I think that goes. Maybe that goes like that. Right. So that goes like that. Now we've got some gears here. And plainly, this one has got to stick up through there. So stop rolling around like that. That one's got to go like that because it engages down there. And then what next? I guess it's one or the other of these 2. So let's assume it's this one. that looks all right on there. So what we've got so far is that this gear is turning the gear under that. So this gear has got to turn that. Right, so now, yeah, that's all right. This one, does that go on here? To hold that down? Yeah, I think so. So now, I think that these two spindles go in those two holes there. Thusly. But that seems to be wrong. Because yeah, that's it. Well, what we can say is that all the gears are brass and they're running on steel spindles which just sit in whatever this is. Don't know what this metal is. Could be stainless steel. There's not an enormous amount of grease on this, but I suppose it's the optimal amount. Well, put it back together again. A point worth noting is that these mounting holes, which are tapped, they go straight through into the top half of the gearbox. So if you were to mount this motor, for example, without using those mounting holes, it'd be a good idea to block them up. Otherwise, the internals of the gearbox is exposed to the elements. If we decided that the unpleasant sounds produced by this gearbox do not bode well for its longevity, the alternative is to perhaps use this stepper motor. This is one that I put on a long-term test for many months, and the gearbox in this motor did not wear at all. But the disadvantage of using a stepper motor is that it consumes more power. By the way, I've had oil in this thing for a week now, and it has begun to seep out onto the table. I've wiped it up now. But I've got no Hanamar. It's still bare metal to bare metal. So I'm not really worried about that. I was going to measure the stall torque of this rudder servo, but I haven't got a flat on the top of the rudder spindle, and I discovered that despite doing this nut grub screw up tightly, it was slipping. So this is not an ideal arrangement, but it's the only way I can mill a flat on that shaft without actually taking the shaft out of the gubbins. To film that. What's actually happening now is it's not slipping here, but the brass gear is slipping on this shaft because I haven't got a flat down there either. I didn't intend to put one down there. being a bit careful because it's 316. I think that will do. It's 1.4 millimeters deep, which is a 6 millimeter shaft, perhaps a bit more. At last I've stopped gears slipping, so am I going to be able to see that? Yes, all right. So let's see if we can store this. About 2 kilograms. One and a half kilograms. Yeah, 1.5 kilograms. So that's 1.5 kilograms. We'll work out the torque in a minute. 70 millimeters. Nine seconds for 2 revs. The other big thing that I need, which I mentioned last time, is that I need to know where the rudder shaft is. Now, there's a Hall effect sensor in here which can count revolutions, and assuming nothing is slipping, that relates directly to the angle of the rudder. But if you lose power, you're going to lose track of where you are. One solution to that will be to continually write the position of the rudder into a erasable memory. But what I would prefer is to have a sensor on this shaft which told me the exact position. The sensors I've used before are the Bourne's, what the hell, I can't remember what type it is. So this contraption is going to be inside a waterproof box with a belt drive to the actual rudder. It has to be like that because there's no room for anything else in Woodstock. So that leaves the option of extending this shaft downwards with another shaft seal coming out here with another belt or a gear taking it over to here, say, and having a position sensor mounted vertically downwards poking out there. All of this is enormously much more complicated than having the whole thing collinear with the rudder shaft, but we just haven't got room in this boat. Of course, if I was a watchmaker, I could make all this much smaller, couldn't I? Anyway, I'm just thinking about that and wondering what to do. Do I need an absolute position sensor which gives you reliable information, or could I rely upon writing the position into an erasable ROM? But you'd have to do it all the time, that's the problem.